Hi everyone. In this video we're going to look at the De Morgan's law. The first law says the complement of A union B is the same as A complement intersection B complement. The second law says the complement of A intersection B is equal to the complement of A union the complement of B. We can also write this law as, if we take the first one, A union B complement is equal to A complement intersection B complement. Second law, we have the complement of A intersection B is the same as A complement union B complement. So let's see how we can prove the first law. Taking the left hand side of this equation, we are going to assume X is an element of the complement A union B. As we have seen in our previous lecture, if I have the universal set S, the sample space, 1, 2, 3. If I have my set A and my set A contains the element 1 and 2, if I want to find A complement, we can write as A prime or A, see, A complement, or simply as a negative of A. So all this notation represents the complement of set A, which means that elements found in A will not be in A complement, and element in A complement will not be in set A. So if I want to find the complement of A, the set complement of A, it's going to be what? The element 3. So we can clearly see that 3 is in A complement, but it is not in the set A. So from here we have X is not an element of A union B, because here it says X is an element of the complement of A union B. So which means that X does not belong to A union B. That is, X does not belong to A and X does not belong to B. Since X is neither in A nor in B. So let's do a Venn diagram. It says X is an element of A union B complement, which means that X is not in what? A union B, which means that and X is an element of B complement. Then X is an element of A complement intersection X is an element of B complement, which implies X is an element of what? A complement and B complement. Hence, the complement of A union B is equal to complement of A intersection complement of B, or A union B complement is equal to what? A complement intersection B complement. The second law follows the same principle as the first one. So taking the left hand side, we let X an element of complement of A intersection B, which means X is not an element of A intersection B. It means that X is an element of A complement, or X is an element of B complement. If we draw a Venn diagram, so A in B. So the first line, X an element of complement of A intersection B, which means that X is not in A intersection B. So X is not in here, right? It means that X is an element of A complement, which means not in A, or X is an element of B complement, which means not in B. Means that X is in here or here, but not in A intersection B. Then we have X an element of A complement union X element of B complement, which implies X element of A complement union B complement. Hence, complement of A intersection B equals complement of A union complement of B. There we have it, the De Morgan's law.